Okay, so in this video, so in the last video for this project 2, the forecasting project, I went through how to download the data and import the data into Excel from Fred. And in this video, I'll go through and show how to create from the Fred data. So you say you are all done getting this core data from Fred. Right, your time, you've chosen your currency, chosen your time period, you've got the spot rate from Fred, UK T-bill, CPI, US T-bill, US CPI. And now from this, what do we need? We need UK inflation, US inflation, and then the inflation differential. And then we also need the interest rate differential. So that's what I'll go through in this video. And then I'll make another video after this one showing how to get these PPP and for how to actually get the forecast. But to get the forecast, because one of the forecasting models is relative purchasing power parity, you need the inflation differential. So let's get that first. To get the inflation differential, of course, you need the inflation. So let's do that. So let me show how I did that here real quick. I'm taking it for granted. You want to put, say you want to put, you could put it here in a blank row, or you can insert a new column right next to the UK CPI. Right, or left click this column E, okay, to select it, and then right click it and hit insert. Excel then always inserts a brand new column to the left of what you just clicked. So let's call this UK inflation. And the way to calculate inflation, there's two ways. One is just find a percentage change. New minus old divided by old times 100. That's the formula that everybody knows. But what we're going to do is we're going to use the difference in logs. There's a number of different reasons why we do that, but we're going to do that primarily because that's just the way that, well, first and foremost, that's the way that we get relative purchasing power parity. We take the logs of both sides, then take the difference in the logs. So in keeping with the theory, we're going to do that here. Second of all, in economics, we use natural logs all the time. So in keeping with that tradition, let's do that here. So to enter, you need a formula. Always when you enter a formula here, I mean, you could bring up here your calculator, view, where's the log here? This would be ln. Here, right here. So log of 42.66, log 42. Oops. 42 point. I never do this on the computer, so around 42.66. Take the log. 3.75, you could enter that. Excel will do all this for you, so Excel has a calculator built in. So equal sign, I'm going to enter a formula, ln. See, then it tells me right here, returns the natural log of a number. So let's take the log of this guy, D3, and then we'll subtract from that the log of the guy before it. See? New minus old. April is later, of course, in the year than January is. New minus old. So that's why I say here, new minus old. See, it highlights it. What is this cell? 0.031487, blah, blah, blah. Where did I get that from? Double click it. Shows you the formula that you used to get that. This is not quite percentage change yet, though. What we need to do is multiply this by 100. This is going to screw up here. Times 100. So 3%. So from the first quarter of 1982 to the second quarter of 1982, the UK had faced 3.148, so 3.15 approximately % inflation. Okay, it's quite a bit actually over a 3-month span. But anyway, Let's do the same thing here. Equals log of new minus old times 100. Okay. Log of this guy minus log of the guy before it. Okay, now multiply by 100. You want to make sure that this times 100 is outside the parentheses. Otherwise, it's inside, and then you're multiplying this last guy here by 100, and it totally screws up the formula. So then you can keep doing that, so on down the road, down the line. But there's even a faster way, so I can do equals log blah blah blah. But again, that would take forever too. Not as long as doing it by this calculator way, but it still would take a while. There's a really quick way to do that. Let's go like this. And Excel recognizes, see here, just going from this, watch this bar here, the formula bar. Going from this one to this one, it shifts D4 to D3 minus D2, D4 minus D3. The next one should be D5 minus D4. So I see the white cross, it's like a thick white cross. It turns to a black, thinner cross right there. That means I'm grabbing this little thick gray, green square here. Grab it and drag it down. See? Log of D5 minus D4. D4 minus D3, D5 minus D4. I can keep doing that. Okay, in fact, I can do it for a bunch. In fact, if I just double click, it'll do it for the whole entire series. So I'm done calculating inflation. Another thing, I scroll all the way down, I don't know what this is. I look at this and I say, is this inflation, the interest differential? What I can do is go up to the top, view, freeze pane, freeze the top row. Now it shows this top row every time I go down. So it's zero inflation over this quarter. And so on. Let's do the same thing for the US. Let's calculate US inflation. See, it doesn't fit here. We'll just double click this and it makes it fit. Okay, so let's do the same thing. I can't calculate this first period's inflation. Why not? Because my time horizon starts in 1982, January 1982. There is no previous period. There is no December 1981. I mean, there is in Fred, but I didn't get it. So we have to start in this second period because inflation is a percentage change. So I could do log of new minus old times 100, or again, we like shortcuts, right? So we can grab this UK inflation, hit right click, hit copy, click over here, left click, and then right click and hit paste. But paste what? Paste the value? No, paste the function, the formula. Then I hit escape and it'll stop that over there. Now look what I did. I didn't have to type this in, it just was already typed in for me. Because Excel recognizes, hey, what are you doing in this column? Excel says, oh, I see what you're doing, Mr. User here. You're taking the column next to me and taking the log, the difference in the logs, times 100. So I can take that formula, I can take this formula that's used here over to this column when it does the same thing. Take the difference in logs, multiply it by 100 of the column next to me. That's what it did. And then again, double click, and there you go. That's the inflation for the US. Now what we need is the inflation differential. I'm just going to call it indiff, inflation differential. If you remember from the book and from the homework and quiz and in-class exercises and so on, The inflation differential comes from relative purchasing power parity, right? Percentage change in S, right? S equals P minus P star. Remember that? Percentage changes. So S here is defined as the spot rate, and specifically it's the dollar price of the pound. So it took $1.78 to purchase 1 British pound back in Q2 1982. So in keeping with this S equals P minus P star, P is the US inflation, again in percentage changes. P star is the UK. Okay? So what do we want to do? We want to take the US inflation and subtract from that US inflation the corresponding UK inflation. Let's do that with a formula. Equals, again, I could do it with my calculator. Bring up the calculator, and I could say, 1.43 minus 3.148, negative 1.7. Negative 1.7. Hey, we want to save time and be more precise. Let's do that. Equals formula. In US inflation minus UK inflation. In the same time period. Make sure they're on the same row because that corresponds to the same time period. Enter. So that tells you the inflation differential. Right? The UK had, essentially what this is saying, the UK had 1.71% more inflation than the US did across that quarter. Now, do we have to do the same thing over here? Yes, but there's a shortcut. Double click. And there you go. Let's do the same thing for the interest differential. So this is what I said, it's intimidating. Look at this. You see this? And it's intimidating. So, oh my, wow, this is crazy. Look at all these numbers. Look, we're there, well, like halfway there already. We didn't even do much. That's why Excel is beautiful. So here's the interest differential. Again, we know from in-class examples, homework, and book readings, and so on. S equals interest differential. R minus R star. Remember that? Again, this would be in percent. This would be in percentage changes. And uncovered interest parity. This would be expected percentage change in S equals the inflation differential. Or sorry, the interest differential. So let's do that again. We have to subtract UK inflation, that's this R star, from US and I keep saying inflation. Sorry, we have to subtract UK interest rates from the US interest rates. Why this? Why this way? Why not the other way? Because we defined S here as the dollar price of the UK pound. So US interest rate, which is the T-bill rate, this guy, minus the UK T-bill rate, this guy. And these are already in percentages, so you don't need to multiply by 100 or anything like that. Enter. And again, double white cross, thick white cross, thin black cross, double click, and that's it, you're done. Again, you can jazz this up by making these centered, whatever. I think they all are already. So that's it for the interest differential and the inflation differential. And then next, in the next video I'll make is going through how to get these over here, PPP implied and so on.